them! Black holes. What are black holes?
A black hole is a region of space that has a gravitational field so intense that no radiation or matter can escape it. Black holes are formed from the gravitational collapse of supermassive stars. They collapse into one-dimensional singularities that hold all of the mass of the original star.
The singularity of a black hole is so incredibly dense and heavy that if you had a black hole that weighed the same as the Earth, it would fit in the palm of your hand.
Since the singularity of a black hole is so dense and heavy, it curves the fabric of spacetime, the four-dimensional continuum that Einstein's general theory of relativity predicted. For a moment, let's imagine that this trampoline is the fabric of spacetime. As you can see, every time I jump, my mass is curving the spacetime. It's pulling it down, so to speak. Let's take a look at my model. Imagine that this is the fabric of spacetime, and this is the singularity of a black hole. Super dense and heavy, remember? Now imagine that this singularity is here on the fabric of spacetime. You can see that its mass curved the spacetime. Now imagine that there was a star or a ball of gas or another object floating through space. If it was just floating through empty space, it would go straight across the fabric of spacetime, undisturbed. But if it was rolling past this singularity, it would begin to curve around it, going into an orbit and eventually getting sucked into the singularity.
So, is there a way to escape a black hole? Well, after you pass a certain point called the event horizon, nope, you're stuck forever. But why? Well, there's a certain speed you have to be going to escape the gravitational pull, called the escape velocity. The closer you get, the stronger the pull. And at a certain point, you just can't go fast enough to escape.
The escape velocity is given where g is Newton's gravitational constant, m is the mass of the object to be escaped from, and r is the radius of that object. The event horizon is a series of points around a black hole where the escape velocity is equal to the speed of light. If an object passes the event horizon, it needs to travel faster than the speed of light to escape. Since nothing travels faster than the speed of light, the event horizon is the point of no escape of a black hole. Another phenomenon that happens when an object is entering a black hole is spaghettification. Spaghettification occurs when there is a difference in the strength of gravity between one end of an object and the other. If you were diving feet first into a black hole, the difference in the strength of gravity between your feet and your head would be enormous. Because of this, your feet would accelerate towards the black hole faster than your head. This would cause you to be stretched out like a noodle, hence the name spaghettification. You would spiral into the black hole in one long stream of atoms.
By studying and observing black holes, we are questioning the very laws that make up our universe. Black holes allow us to test some of the fundamental theories of our universe and lead us into new areas we haven't even begun to explore. As physicist Richard Feynman once said, "I'd rather have questions that can't be answered than answers that can't be questioned."